So in this video, we are going to do the notes for Chapter 7, Section 1, and our goal is to classify, add, and subtract polynomials. We're going to begin with classifying and several definitions. So there's two different ways you can classify polynomials. The first way is to classify by the number of terms. Terms are things that you're adding or subtracting. So we'll actually start with an example which is called a trinomial. So a trinomial has three terms. For example, x to the fourth plus 8x plus 1 is a trinomial because there are 1, 2, 3 things that we are adding. Tri comes from the root, it's the root for 3. So think about like a tricycle has 3 wheels. A bicycle has 2 wheels, and sure enough, when we have a polynomial with 2 terms, it's called a binomial. So a binomial has 2 things that we're adding or subtracting. For example, 4x to the second minus 7. The most basic polynomial is called a monomial. Just like monotheism is a religion where you believe in one God, a monomial will only have one term. For example, 3x, just the one thing. It's not really being added or subtracted, it's just this monomial, right? Number of terms. 1 term, monomial, 2 terms, binomial, 3 terms, trinomial. We can also classify polynomials by the degree, which is the largest exponent of the variable. The most complex example that we'll get into in Algebra 1 is called a cubic. And an example of a cubic would be 11x to the third minus 6x. The reason this is a cubic is the largest exponent of the variable is 3. We could also have the largest exponent of the variable could be a 2. And if that's the case, we would call it a quadratic. A quadratic would be a polynomial with a degree of 2. If the degree of the exponent, like this case, the degree of the exponent was just an x, so that's an x to the first power, we would call that a linear polynomial, because if you were to set it equal to y and graph it, the graph would be a line. And the most basic polynomial by degree is a constant. It's just a number like 12 or negative 8. And the degree of a constant is 0. It's like a variable to the 0 power, right? So no variable visible is a constant. A variable to the first is linear. A variable to the second is quadratic. And if the polynomial has a variable to the third, that would be cubic. To write a polynomial in standard form, the exponents of the variable should decrease from left to right. So we see x to the third, x to the second, x to the first, and then x to the 0, or no x's. This is in standard form. The coefficient of the variable with the greatest exponent is called the leading coefficient. So the number in front of whatever x to the highest power is would be your leading coefficient. In this case, the leading coefficient would be 5. Okay, rewrite in standard form, classify by the number of terms and degree, and state the leading coefficient. So let's talk about, here we've got a polynomial, and I'm just going to copy it so I can rearrange it easily. So to put it in standard form, you need the x squared at the beginning, because that's your largest exponent of your variable. And then if we're going to classify by the degree, this has got something to the second power, which makes it quadratic. By the number of terms, there are 3 terms, which makes it a trinomial. And the leading coefficient is going to be 4. For 8x to the third, it's already in standard form. No need to rearrange. It is cubic because of the x to the third. It is a monomial because it's just the one term. And your leading coefficient is 8. Finally, For 9x minus 1, we have to put the 9x at the beginning. The variable to the first power comes before the variable to the 0, right? And this one is going to be a linear binomial. So it's linear because you've got an x to the first power, and it's a binomial because there are two things that we are adding together, or in this case, subtracting. And we're going to add these polynomials by combining like terms. So for the first example, I have 20x squared plus 23x squared, and 20 plus 3 would give me 23x squared. Oops, what did I do there? Okay, 8x, there's no other linear term, so that will stay by itself. And then a negative 7 plus a 12 would be plus 5. Here, I've got a negative 4y squared, a 1y squared, and a negative 9y squared. So my y squareds are like terms. So negative 4 plus 1 is negative 3, plus a negative 9 is a negative 12. Negative 12y squared. And then I've got a 2y, and a 1y is a 3y. And then I have a negative 11 plus 8 is a negative 3, minus 7 is a minus 10. Negative 4 plus 1 is negative 3, minus 9 is a negative 12y squared, 2y plus 1y is a 3y, and a negative 11 plus 8 is a negative 3, minus your 7 is your minus 10. To subtract, you have to watch the signs. So the way I like to view subtraction is I like to view it as if you are adding a negative 1 that you then distribute to the second set of terms. So I'm going to leave my first set the same, and when I distribute a negative 1, what happens is this becomes a negative 4, a positive 5, and a negative 1. So you have minus a 4x squared is the same thing as plus a negative 4x squared, minus a negative 5x, well, a negative times a negative, that's the same thing as plus 5x. And then in subtracting, we're subtracting this 1. So a negative distributed flips that to a minus 1. I think it's easier to focus on adding. So I just switch this to negative, plus, and minus when I make this adding the opposite. So 11 plus a negative 4 would be a 7x squared. And then a negative 2x plus a 5x is a 3x. And then 6 plus a negative 1 is a plus 5. So 11 minus 4 is 7. Negative 2 minus a negative 5 is negative 2 plus 5, which is 3. And then a 6 minus 1 is a 5. Same idea for this second example. I'm going to go ahead and, where did that go? There we go. Copy it. And I'm going to change this to plus negative 1 times each of those things. The first term will stay the same. The second term will become the opposite of what it was originally. So plus a negative x squared, plus a 12x, plus an 8. Negative times a positive, negative times a negative, negative times a negative is a plus. So subtracting in the x squared, subtracting the negative 12x is adding 12x, subtracting the negative 8 is adding the 8. So 7x squared plus a negative 1x squared is 6x squared. And then there's a plus 12x that does not have another like term, and then a 3 plus an 8 is a plus 11. Finally, sometimes we've got lots of variables, in which case the variables have to match each other exactly to be considered like terms. So we're going to change this to adding the opposites. So subtracting a negative is adding, and then subtracting a positive is subtracting. So subtracting a positive, adding a negative, these are equivalent. There is an x cubed y and a negative 7x cubed y. So that'll be a negative 6x cubed y. 1x cubed y minus 7x cubed y is a negative 6x cubed y. And let's just use a little color coding just so we can kind of keep track of where my like terms are for this last one. I've got a negative 3x squared y squared, and that's going to match with a plus negative 9x squared y squared. And so negative 3 plus a negative 9 is a negative 12. And then these last two are not like terms because although they both have a y to the third, this one has an x. So since those cannot be combined with another term, they will be placed at the end.